Okay, let's start with our R and let me import my same file. Okay. Now we are working on the same file. So let me attach this file. Now over here we will be library two packages. One is library T series and one is library RuGarch. RuGarch is a univariate Garch. So we are doing, first of all, we are going to learn your standard Garch, E-Garch, GJR Garch, and all are univariate Garch. That means we are going to study volatility only for one variable. We are not going to study volatility for more than one variable. So what we can do, if you are writing a research paper, you can just forecast the volatility of one variable, or what you can do, you can compare the which model is best in each of the variables. Suppose I am calculating the volatility of this model, I'll calculate symmetric also, I calculate asymmetric also for N2 to 5. And in asymmetric, I am calculating for E-Garch also, I am calculating for GJR Garch also, I am calculating for mean Garch, I am calculating this P-Garch, I am calculating your power Garch. So I am calculating all these types of Garch, and then I am comparing that for calculating the volatility of N2 to 5, which Garch model is a best fit. So there are different ways you can use your Arch and Garch model. Okay, everyone has attached the file and you have uploaded the this library.
Excuse me, ma'am.
Yes.
Ma'am, here we have to test all the type of Garch models and we have to find out which Garch is best.
Up to you.
Is it?
I think it depends on your objective. Suppose my objective is just to find the volatility, future volatility. That means I
Okay.
want to find out the volatility 10 days ahead or 20 days ahead. So what I'll do, I'll use a simple Garch model. That means I'll use a simple standard Garch model, right? Or
Yes.
even you can use only one model, E-Garch model, or you can use GGR Garch model, depending whether you think that your volatility is symmetric or asymmetric. It can happen that volatility can be symmetric. It can happen your volatility can be asymmetric. So depending on the literature, depending on your thinking, whatever variable you are taking, depending on that, we will go with one Garch model only. Okay, if
Okay.
you want to just go for volatility. Now you want to fit a best model. You want
Yes.
to know that in my one variable, which Garch model is a best model. In that case, I will go with 4 or 5 Garch model, and then I will find out these are the 5 models which is the best model. For example, if I'll say, I'll just give you a small example. I am at home and I want to go to college, right? And in the morning, whenever I'm going to college, there are two different ways to go to the college. I
Yes.
want to choose the shortest distance, right?
Yes.
Suppose if I want to choose a shortest distance, what I'll do? One day I will travel from route 1. Second day I will travel from route 2. And once I have traveled from both the routes, I will decide that which route is the best, right?
Yes,
This is
ma'am.
one of the way to decide. Otherwise, what I can do, I can on my own decide that yes, this route 1 is the best model. I will never go with the route 2. It's my thinking. So it's up to you. If you're starting the research paper, you have already thought that this model is the best, you can go with one model only. So my
Is the
objective is to find out the volatility. So I'll go with one model with N2 to 5, with the same model BBSC, with the same model SSCI. I'm going to find the volatility of all the three. And then I will find out that yes, I am using the standard gauge model and this volatility is more than this variable volatility. This is one of the way. Or you will choose all the models. You will first of all study all the models and then find out which is the best model. Again, depending on your objective.
Okay, ma'am. Yes, ma'am. Thank you.
Okay, now we have library both the packages. So what we have learned yesterday that whenever we are going with any arch and gauge model, there are preconditions. We have to fulfill the preconditions that whether I can use this arch and gauge model or not. So the first condition is that your data should be stationary. I cannot use arch and gauge model on non-stationary data. Second precondition says that there should be volatility clustering. Volatility clustering should be there. And third precondition is there should be arch effect. If you are finding these three conditions are fulfilled, then we are going to apply the gauge model. If these three conditions are not fulfilled, we cannot apply the gauge model. But you will hardly find that the condition is not fulfilled. But still, if you find that in any way, because if I was also writing one research paper where I find that uh, arch model is not there, but these two things are there. That means data is stationary, I have converted into stationary, and volatility clustering is there. So even if the arch effect is not there, I applied the model and I was able to successfully run all the things. So sometimes it happens that without the arch effect also we can do it, but arch effect is there, but somehow R is giving that there is no arch effect. So don't worry about that. Even if the arch effect is not there, you can go with the volatility model. So we have already tested in the previous days that my N225 BVSP and SSCI are not stationary. So let me convert it into stationary. So Rn225 equals to diff log N225. So this is my stationary. Let us check it. ADF.test Rn225. So your data has now become stationary. So I will be calculating the volatility only on Rn225. As we have done in ARIMA model, what we are going to do, we can calculate from N225, that means original series also, but we will be giving instruction to R that first convert it into the difference and then apply the ARIMA model because we are writing in the integrated part 1. But over here, we cannot do this. So first of all, we have to convert the stationarity and then only we can apply the volatility model. Next is to we have to check whether there is a volatility clustering or not. Volatility clustering means your smaller changes are followed by smaller changes and larger changes are followed by larger changes. Got it? So, and how we are going to check it? By plot. We are going to make the plot.ts and Rn225 because we have to work on this data only. Now see this diagram. Are you able to see all the spikes? See, these are the spikes. From zero, mean is there. That means if I'm going to draw a straight line, mean falls from zero. We have already learned that volatility is a model which has generated from the mean model. ARIMA is a mean model. Without mean, I cannot calculate standard deviation, and without standard deviation, I cannot calculate the variance. So now you will see that changes are there. And changes are not constant. Heteroscedasticity is there. As we have learned, Arch model says autoregressive conditional heteroscedasticity. The changes are depending on its past. Now you can say that if this is a large spike, previous spikes are also large. And if you will see over here, small changes are followed by small changes. Your large changes are followed by large changes. So this is known as volatility clustering. When large changes are followed by large and small are followed by small. There is a clustering over here. This is a part. This is a clustering. This is your clustering. This is your clustering. Got it? So you have to see these effects. And let us check the arch effect also. Autoregressive conditional heteroscedasticity. Now you can observe it that if I am saying this spike, this is depending on its immediate previous spike. Because previous also it's a large one, it's not a small one. If I'm going to see it over here, small one, it is depending on its immediately previous spike. So arc effect is there. Arc is saying that all the volatility is depending on its past. Now let's check for the third precondition, arch effect. So for that command is arch test. Just apply arch test. Let's see whether you are getting arch test or not. I think there's some problem in this. Just apply arch test. Just see whether you can get it or not, because I am not getting in drop down menu. Arch test RN225. Have you checked it whether you are able to get it or not?
No, ma'am, no.
Okay, let me library two more packages then. Okay, library FinTS also. Financial time series and library one more package E1070. Done. Library financial time series and E10701. Right. Done. E1071. Now arch effect, arch test. Yes. Arch test is the command under FinTS. So arch test RN225. Now in arch test, you can see that it's written over here that null hypothesis says that there is no arch effect. So H0 means no arch effect and H1 means arch effect. That arch effect is there. Now here you can see that p value is less than 0.05. It means we will go with the alternative hypothesis, and alternative hypothesis saying that there is an arch effect. So my first condition is fulfilled, data is stationary. Second, volatility clustering is there. We have seen it from the diagram. And third, arch effect is there. So all the three conditions are fulfilled. Done? Any doubt till here? No doubt? Okay. Now we are going to find what is the best gauge model. As you remember, in ARIMA model, we have used the command auto.arima, so that R will tell me that which is the best ARIMA model. Similarly, we are going to use the command for the GAR charts also, that which GAR model is the best one. That means if there is an arch effect, how many lakhs, that means today's value, today's volatility or today's error term square is depending on which previous lakh. Mostly if you will see any research paper, you will find that your arch and GAR model is on 1-1 basis. That means arch 1, GAR 1. So for that, the command will be, so fourth step is to find out the GARCH model. So now I'm going to find out the GARCH model. So command will be GARCH. Now you have to write the series name RN225, comma, grad. That means now I'm saying that use the numerical and just tell me which is the best GARCH model. So numerical, comma, trace equals to true. Got it? Now, if you will observe, the coefficients are A0, A1 and B1. A0 means your constant term, A1 means your arch term and B1 means your gauge term. If you remember yesterday I told you arch is developed by Robert Engel and gauge is developed by Bosgrave, and Bosgrave is a student of Robert Engel. So just to give the regard, the teacher is coming first and the student is the next to him. Arch model is a error term model and gauge model is your volatility model. Arch model is saying that error today's today's volatility is depending on the 1 day back error term. Whatever the news has come yesterday, that is affecting the volatility of the share price in today's day. And beta 1 is saying that today's volatility is also affected by the volatility of the previous day. Got it? So that means my GARCH model over here is 1-1. So my GARCH model is 1-1. Now, whenever I'll be creating the GARCH model, I'll be using 1-1. Clear? Okay,
Ma'am,
now
can you
let's,
repeat it once again, please,
which
ma'am?
thing? Which?
Ma'am, that's the interpretation of the Gauge model, how we get 1-1.
Till now we have not covered the GARCH model. I've just told
No,
you.
ma'am,
But
the 1-1, how can we get the 1-1?
see,
This.
this is my command.
Yes,
Guards,
ma'am.
I've just given the guard and whatever
Mm-hmm.
variable you have to choose that. And I'm saying that from the complete, this is a just command numerical phrase true. So
Okay, ma'am.
after that, once I click it, it gives me that the
Mm-hmm.
guards model should be 1-1. A1,
Okay,
A0 means constant. A1
mm-hmm.
means your arch term.
Gosh.
B1 means your guard term. And I'm not getting A2, A2, A3. So if I'll get
It's
A2
one.
also, so
All
it
right.
will be 2-1. So if
2-1.
I'm
Okay.
getting A1, B1, so my GARCH model is 1-1.
All right. Thank you, ma'am.
So I am able to get that this is my GARCH model. Now I will create a model. So for that, let me give the let us again store some in some variable. You can give any name. Let me give the name to be RN225 underscore GARCH. Now I'm creating a GARCH model. So as I will be storing the GARCH model in this vector. So you will be using uGARCH spec. That means what I am saying to R that I am working on univariate GARCH and you have to speculate the future. So uGARCH spec. Why we are studying this arch and GARCH model? Because we want to forecast the volatility. That means we have to speculate it. So I am saying uGARCH spec, and now we have to give the instruction whether arch and GARCH is a mean model or variance model. And we all know that arch and gauge is a variance model. And variance model has come from the mean model. So it's up to you whether you want to get the results of mean model as well as your variance model, that means ARIMA model, as well as your arch and gauge model together, or you just want to get the answer for variance model. So first of all, I'll write variance dot model. You will see that each and command will be there. Now you can see the all the commands are there. Variance model equals to list gauge order. Now we have to give the order. If you remember in the ARIMA model, we have used the command ARIMA, comma, order is equals to C bracket 101. Similarly, over here also we have to give the order that we have find out that our order is 1 1. We have find out my order is 1 1. So list gauge order. So my gauge order is equals to C 1 1. This is my gauge order. And I know that gauge, that means this variance has come from mean model. So I'll write mean dot model equals to list ARMA order. Now I'm not writing ARIMA. Do remember ARMA order. Now if you want to get the answer for ARMA order also, so you can write C11. And if you don't want to get the answer for ARMA order, you can write C00. C00, if you write C00, it will not give you the answer for ARIMA model. It will give you the answer for only the arch and gauge. And since I am writing ARIMA model also 1 1, it will give me the answer for ARIMA. I can use 2 1 2 2 depending on the ARIMA order, that ARIMA model, which model I am going to create it. Wait a minute. It's Rn2 to 5 underscore gauge is equal to U gauge spec. Variance dot model is equals to list gauge model is equals to C11. Mean model is equals to list ARMA order equals to C11. You just try this command also, whether you are able to get it or not. Okay, I got the mistake. I have put dot over here. It should not be dot. Now, done? Done till here? Now, I have stored the command in Rn2 to 5. Now, I'm going to fit the model. So, let me give the command Rn2 to 5 underscore guard underscore fit. I'm storing the command in this equals to uguard fit uguard fit. Now I'm going to say that fit the model using this command. That means I have stored the uguard univariate gauge variance model in Rn2 to 5 underscore gauge. So using this model, just create it. Uguard fit comma data is equals to Rn2 to 5. Now just write Rn2 to 5 underscore gauge fit. It will give you the result. Now just see over here. These are the results that I have to see. See, gauge model fit. We have used standard gauge 1 1. We have used ARMA order. ARMA 1 1. So ARIMA will be 101 because I have not given the integrated, so it's understood it will be 0 because we are working on the return series. And you will see that it has given me the constant for mean AR1, MA1 term. Omega is your constant for variance model. Alpha 1 arch effect and beta 1 is your gauge effect. And you will see over here all your parameters, all your estimates are significant. Got it? Any doubt till here? What we are going to quote? We are going to quote this result. So whenever you will be making the equation, you will be using this result. For mu AR1, MA1, it's up to you whether you want to use it or not. In equation, I will be writing your Rn 2 to 5 T. Let us write it over here. So Rn 2 to 5 T, let me write T is equals to your omega, that means 0.00008. You just see the zeros plus 0.145, 0.145 and your 0.145901. This is your error term e ki power square e ki power 2 and it will be t minus 1 plus your 0.803 and it will be your Rn 225 T minus 1. So this will be the equation that how you are going to write the equation. That means today's volatility is depending on some drift, some constant plus 0.14901 times the lag 1 error term plus 0.803 times the previous day volatility. Okay, now your what do you mean by alpha 1? It's clear that alpha 1 will be teaching you that whether there is a volatility in your model or not. So since alpha is getting 0.145, so I can say there is a volatility. There are some changes in my error term. Got it? And beta means since beta is also positive, so it is telling me yes, that there is a persistence in volatility. That volatility exists. It's a persistence in volatility. Got it? Meaning of your alpha and beta? What do you mean by persistence? Are you able to know what is the meaning of persistence? Anyone having any idea about the persistence? Now see over here, your beta is also positive and your alpha is also positive. And beta is 0.803. That means larger amount of beta. So whenever you are having the larger amount of beta, it indicates that your conditional variance will decay slowly. And if it is smaller, so it will say that your conditional variance will decay quickly. As more and more value of beta you are getting, decay is slow. That means the effect of today's volatility will be long lasting.
Excuse me, ma'am.
Yes.
Can you please explain me once again, ma'am, the persistence thing?
Persist. See, alpha will tell you your whether there is an impact, whether the news has impacted the volatility or not. Alpha will tell you this thing. If over here the positive alpha is there, so that means whatever news is there in the market that has affected my variable. That is Arch is telling. Now beta is telling whether there is a persistence is for the longer duration or shorter duration. That means whatever change we have find it out by alpha, alpha is saying some change is there, 0.145 something is getting some changes there. But how long the change is, that will be told by your beta. As more and more value of beta will be there, so that means persistence is longer. That means whatever volatility, conditional volatility will decay, it will be reduced slowly. And if it is less, suppose it is 0.203, so it means जो conditional volatility is there, that will decay quickly. And the next condition that what you have to see, that your alpha plus beta should always be less than 1. Should always be. It should not be more than 1. So you have to check your post condition, your alpha plus beta. Whatever is your alpha and whatever is your beta, it should be less than 1. It should be less than 1. Now you can check it over here. If I am going to add these coefficients of alpha and beta, it will be let's say do it from here, 849, 948 or 949. It will come about 0.949. So which is less than 1. So if it is less than 1, it is saying that volatility, conditional volatility is decaying. As the time passes, volatility will fall down. The impact of news will reduce. Over here, you can see that suppose over here COVID is there. This is a COVID period. As the COVID arrives, news of COVID is there, volatility is more. But as the time passes, the effect of news is decreasing. I'm not saying it's zero. We are just saying that as the time passes, the effect of volatility, effect of news is decreasing. So that's what it's saying. If alpha plus beta is less than 1, volatility decays. As the time passes, volatility will be falling down. Got it? And suppose you get the answer for alpha plus beta is greater than 1. What will you do? If your answer comes out to be greater than 1, then you cannot apply any other gauge model except your I gauge. Over here, first of all, right now I have applied your symmetric gauge. I'll show you the graph, how it comes to be symmetry. If alpha and beta comes out to be more than 1 and I have to apply a symmetric gauge, then I will be doing only T gauge, I gauge, only I gauge. And if it is less than 1, I can apply E gauge also, I can apply GJR gauge also, I can apply T gauge also, P gauge also. Any type of gauge I can apply it over here. Now let's see
So, ma'am,
that
in
best.
order, sorry, ma'am, and in
Yes,
order
yes.
to apply asymmetry, we have to check the standard gauge first, so that we
No, no.
can. Mhm.
It's up to us. I can directly use E gauge also, but yes, standard gauge gives us an idea. Now
Idea.
you will see, yes, you will see that if alpha value, this arch effect, answer comes out to be negative somehow. So that means there is an asymmetric. Now you will see alpha is also positive, beta is also positive. So there is a symmetry over here. Otherwise, second part, you can see the sign test over here. See, this is a sign bias test. Are you able to see sign bias test? Sign bias test is not significant. The p value is 0.6953. So since this is not significant, so I can say that I can go with this asymmetric model also. If it becomes significant, na, automatically alpha will become negative. The answer will become negative, and it says that you have to use the asymmetric model. You can use the asymmetric model also, and I can use E guard, GJR guard, P guard, T guard, I guard, mean guard, आप कुछ भी use कर सकते हो, that means. Now, let's take whether it's a symmetric or not, because we have to prove it and we are using the standard gauge. So my diagram should be completely symmetric. We all know what is the meaning of symmetry. For example, your letter T is a symmetry. That means if I'm going to fold it from the zero, from the middle, it will overlap each other. Overlap means good news and bad news have a same impact. If good news has a 10% impact, bad news is also having a 10% impact. Got it? So let us make the diagram. So let us again store it in some variable. So let me give the name RN225 news impact. Let us give this name news impact. I just want to see whether whatever the external news is there, whether they are having a symmetric same effect of bad and good news or they are having a different impact. So this is equals to news impact and name of the model. My model name is RN225 underscore gauge underscore fit. So my values I am going to ask about the news impact. It is being stored in this variable RN225 news impact. Now I am going to plot it. Plot RN225 news impact $sign your ZX comma RN225 news impact $sign ZY. One time take ZX and one time take ZY. Now next is your, now I have to give the label Y lab. Y lab means Y label. I have to just give the Y label, what should be the label at the Y axis, and then I'll give what should be the label at the X axis, and then I will write the name. What should be the name written over here? So Y label is equals to, again our variable name is RN225 news impact $sign and YEXPR comma X lab is equals to RN225 news impact $sign your XEXPR comma main. Whenever in any command, if you are writing main, main means you what heading you want to give. So I want to give the news impact curve. So what will be the news impact curve? So I'm giving this command. Now see over here. Your news impact curve is generated. If you will see, this is 0. If I'm going to see over here, if I'm going to draw a straight line from 0 and I'm going to fold it, it will be completely overlapping the other part. This is your bad news. This is your good news. So over here, you can see negative news. Negative means bad news, and over here is a positive sign, which means good news. So if some negative news is there, so prices are decreasing. Volatility is decreasing by whatever percentage. Prices are decreasing by whatever percentage, and by same percentage, if good news are there, the prices are increasing. So that means this is symmetric, completely symmetric diagram. So S-GARCH is a symmetric model. This is one of the way to find out the symmetric, whether the data is symmetric or not, because we have already done. We have to prove it by your test also, that we will be creating the model, and we can prove it by diagram also. So in research paper, you have to show your diagrams. It's up to you whether you want to show the diagrams or not. But mostly diagrammatical presentations as well as tests both are required in the research paper. So this is one of the way. Another way. So I'll just write plot and my model name is RN225 UGART fit. Now see over here. There are, you can make 12 different plots with this diagram, this command. Just write plot and all these diagrams are there. I just want to make a news impact curve. So I'll write 12 over here and it will give me the news impact curve. Got it? So there are two ways to make the diagrams. It's whatever way it suits you, you can do it. By if you are going to write it one, it will give you the conditional standard deviation. See, it will give you two conditional ST. If you are going to write two, whatever diagram you want, it is going to give you. If you want to calculate ACF, it gives you the ACF also. If you want to find the cross correlation between variables, it will give you the cross correlation. But right now you will not be able to understand what these diagrams are saying. So just for the basic learning, you can go with the news impact curve. Now, if you want to come out, you can just press 0 or write exist. You will be out of these plots. Got it? Now, next thing is that we have to forecast. How I have to forecast the volatility. So for that, I will be storing the command in forecast. Let's say forecast underscore RN225. I just want to forecast the volatility. So I'll write the command uGauge forecast. uGauge forecast and then your command for variable is RN225 underscore gauge underscore fit and comma n dot head. If I want to calculate only 10 ahead volatility, so I'll be using the command n dot head equals to 10. So your all the future volatility is stored in forecast underscore RN225. Now I'll write forecast RN225 and enter. It will give me the forecast T plus 1 till 10. Sigma represents your standard deviation, your risk, and this is your volatility. Future 10 volatility. And if you want to predict the volatility of more than 10, that means I want to predict the 11th day volatility, 12th day volatility, then what you have to do, instead of n dot head, you will be using n dot ahead. N dot ahead 20. If you are going to use n dot head equals to 20, you will again get only 10. For example, I'm using n dot head equals to 20 and then I am going to apply forecast RN225. See, it will give me only 10 values, future 10 values only. But if I'm going to write n dot ahead, now I'm writing n dot ahead and again I'm going to write forecast RN225. See, it will give me 20 values. So depending what values you want, you can predict it. Any doubt till here?
Ma'am.
Yes.
Hello, ma'am.
Yes.
Ma'am, if I change the say n dot head, it will be 20. So it didn't show me the 20 data.
It will show you 20 data.
But ma'am, ahead. Then what is the difference between ahead or head?
Head is a command only for 10. That means if you want to predict only till 10 days, you will using the command head. If you want to predict more than 10 days, you have to use the command n dot ahead.
Okay, ma'am. Okay, ma'am.
See, if I want to get the values for let's say 30 days, so I'll be using n dot ahead only and I'll be using forecast and 2 to 5. It will give me see T plus 30. So if you want till 10, use the command head. If you want to use more than 10, 11, 12, 13, use the command end dot ahead. Got it? Any doubt in this?
No, ma'am. No, ma'am. Thank you, ma'am.
Okay. Now, gauge is clear. Standard gauge. Can we move to asymmetric gauge? This is was a symmetric gauge. Now, let's move to the asymmetric gauge. Okay. I have to just open my asymmetric. Okay. Now, let's go with the one of the asymmetric gauge. We will be doing two types of asymmetric gauge, E gauge and GGR gauge. These are the most common ones. Otherwise, you have P guards also, you have T guards also, you have I guards also, you have power guards also, you have mean guards also. So various kinds of guards are there, but mostly we use these two. Okay, now if you remember, when was your standard guard was invented? Your standard guard was invented in 1986. Balls were invented in 1986. And standard gauge is saying that bad news and good news have a same impact. But actually, in real life, you will never find that some good news and bad news is having a same effect. For example, if I say that you got a good job or you got a promotion, okay, you will be happy for how many days? 1 day, 2 days, 3 days, 4 days, 5 days. And after that, it will be a routine thing. Or you get the best teacher award. So you will be happy. But how long is a persistence? How long you are happy? So maybe 2 days, 3 days, 4 days, 5 days. But now somehow I say that there is some bad news. Someone expired in your family. That is a bad news. So how long will that effect is? Only 1 day or 2 days, 4 days, 5 days, 10 days. It will have a longer effect. If someone very close to you expires, you will have a longer effect. And if some child is born in your family, you are happy. But for how many days? Someone expired is a bad news. Someone born is a good news. So bad news has a longer impact. Good news has a shorter impact. It's a real fact. COVID-19 is a bad news. So whenever COVID-19 came, we all remember for a longer duration of time. But if the company is giving you dividend, how long you are going to remember that yes, this company paid me the dividend due to which I earned more money in the stock market. We won't remember this. So that means good news mostly in real life. I'm not saying good news is not having the longer impact, but in real life, good news and bad news will never have a same impact. If bad news came, people are going to take out their money. If you remember in COVID-19 only, I'll give you one more example. There are many companies who are manufacturing this COVID-19 vaccine. But Pfizer is one of the companies that gives in advance, that gives the news came in the market that Pfizer is a US company which is going to make a COVID-19 vaccine. And since we all want the COVID-19 vaccine because this is a pandemic, this is a health issue pandemic and people are dying. So we all need the vaccine. We are all are frightened with this news. So Pfizer gave the news that the Pfizer is going to make the vaccine. And you will see that the stock market of Pfizer shoots up because that was a good news. Suddenly it shoots up. So it can happen that bad news can have longer impact than good news, but sometimes good news can also have a longer impact than bad news. So whenever you will see that good and bad news are not similar, giving me similar impact, I'm going to use this E card. So S card has this drawback. That was a thinking that they have a similar impact, but actually there is not a similar impact. So E guard was invented. So EGARCH was the first model which was able to incorporate your asymmetric volatility. And these are some of the research papers who have studied that, shown that EGARCH is more accurate result, that I was telling it to you, that many researchers has done. Even in my one of my research paper that is going to publish recently, that means it's being accepted, but maybe it will be published within 1 or 2 months. So in that, I have also taken the various models, and I also find out that EGARCH model is the best model among various countries. I have taken the stock market of various countries, and then I compare that which model is best in most of the companies. I took 5 different countries, and then I compare your SGARCH, EGARCH, and GJR, and I found that in 4 of the countries, EGARCH was the best model. And in one country, GJR-GARCH is the best model. So my net result was that EGARCH is the best model to forecast your volatility, to calculate your volatility, to see the impact of volatility. EGARCH is the best model. And you will find many research papers where EGARCH is the best model. So whenever you are writing research paper, you have to validate your research with your previous literature. So in that case, you will write that these are all the research papers where I find out that EGARCH is the best model, and I also found that EGARCH is the best model. So I'm validating my result. I'm doing the diagnostic check for my result. Okay, now whenever we are doing the EGARCH model is a log model. It is a log model. And what do you mean by word log model? Any idea what do you mean by word log model? Log model says whether your value is negative or positive, it will not impact any volatility. It's one and the same thing. So that's why, since it is a log model, we get more accurate results. If you will remember that whenever we are taking the stationarity, we also take the log. So over here, whenever we are using the log model, we will get the better results. And similarly, whenever we are using the asymmetric volatility, we have one more parameter, one more estimate. In your standard gas, we are saying that there is no asymmetric, there is a symmetric. So we were using one omega, that means constant term, one alpha, your arch term, one beta, one your gauge term. But over here, I will be using one more term, gamma. Gamma means your leverage effect. So whenever we will be talking about asymmetric volatility, one more parameter is added, gamma. Now, any one of you knows what is leverage effect? What do you mean by word leverage? And this leverage only, your gamma, will tell you whether there is a asymmetric or not. This gamma. Okay, let me tell you this thing. Now see over here. Let me see. See over here. If your gamma is 0, that means no asymmetric effect. Your data is symmetric. That means good news and bad news have a same impact. If gamma is 0. If gamma is less than 0, that means if negative news, gamma is less than 0 means whatever your estimate will be in the negative sign. It means negative shocks will increase the volatility more than positive shocks. If some negative news is there, negative shocks are there, volatility will be more than when the positive news is there. If in negative news, COVID-19 news is there, volatility is 20%. Dividend increase, dividend is given, or companies having more profit, volatility, good news is there, or companies issuing bonus shares, good news is there, volatility is 10%. So whenever you will see negative sign, you have, this is an indication that negative news has more volatility than the positive news. And if your gamma is positive, it means positive news increases the volatility. Positive news has more volatility than the negative news. Got it?
It means, ma'am, we are using this gamma as a leverage.
Yes. So gamma is leverage only. See, gamma is a asymmetric volatility which tells us about the leverage. Now, anyone having any idea what do you mean by leverage effect?
Ma'am, it is something like that if we are using something in order to enhance something. For example, if we are using this debentures in order to enhance the equity shareholders that we
Okay,
studied in
yes,
capital
yes,
structure.
yeah, capital structure. I'll just tell you capital structure what happens. See, capital structure that means that whenever you are having any company, you will never find a company with 100% debenture. No company will be there with a 100% debenture. What do you mean by word leverage? Because I never teach anyone that you have to cram the thing. What is the word leverage? Okay, what do you mean by word lever? Just think about the wording that we are using.
Madam,
Whenever you,
madam,
yes, what is lever?
use of debt for equity.
Yes, that is a use of debt for equity, but I am asking what is lever? Have you seen in physics? We have learned in physics
Yes,
lever. My
to
elbow,
move
movement,
easily, madam.
movement, movement is fixed. Something which is fixed, we name it as a lever. At this point, something is fixed. We have a seesaw. It is fixed at a lever. So lever means fixed. So similarly, in finance, word lever means fixed financial cost. And fixed financial cost is whenever we borrow the money from the investors. Either we are taking, either I am issuing bonds or I am issuing loans, I am taking loans, or I am issuing the debentures. So if I am issuing these three things, I have to give the fixed percentage to the investors. If I have taken loan from the bank at 10%, whether I am having profit or loss, I have to give 10% return. If I am issuing bonds, whether I am having profit or loss, I have to give the fixed amount of coupon rate which is mentioned. If I am issuing debentures, I have to pay fixed amount of interest to the debenture holders. That means fixed cost is there irrespective whether I am having profit or loss. So what happens if somehow in a company asset price decreases? If asset prices are decreasing, what is happening that company has to borrow the money from the market because company cannot go for the equity. Asset price is decreasing, so we cannot go for the equity. We have to borrow the money either in the form of loan, bonds, or debentures. If I am going to borrow the money in the form of loan, bonds, and debentures, it means that my proportion is for proportion for the loan or debenture is increased. If proportion for the loan and debentures is increased, it means more interest is being given from the profit of the company, and profit is for the whole year. It is same. If more profit is given, it means less amount of disposable income is left for the equity shareholders. And we all are aware whatever amount is left after paying all taxes, all loan interest, everything after paying, whatever is left, that is a equity shareholders fund. So that means equity share, if proportion of debt is increases, the amount for equity shareholders is less. So that means equity becomes more riskier. Equity shareholders will say that yes, the proportion of debenture is increasing. It is affecting us because they are being paid from my dividend. If debt is decreased, I must have got more dividend. Now debt is increasing, proportion of debt is increasing, the equity shares are becoming more riskier. So that's why we name it as a leverage effect. Lever, more fixed cost is paid. That's why risk is there. So your company's stock will become more risky. Got it? So in simple terms, I can say that if the debt proportion in the capital structure is increases, my volatility is affected. And I'm going to see the leverage effect. And there will be the negative correlation between the past and present returns, which means your negative impact will be there. Negative impact will have more volatility than the positive impact. which means if the price decreases, volatility increases. I have told you my asset price decreases, more debt is being borrowed, which means your volatility increases. Investors, all those people who are invested in the equity shares, there will be the fluctuations in the mind that we are getting more risk. More risk means more volatility. Got it? Any doubt in this? What do you mean by word leverage that we are using over here? How the leverage impacts? Now, over here, see, I am saying there is a negative relationship. Price increases, volatility decreases. Price decreases, volatility increases. Now, see over here. See, price decreases. Are you able to see this red line? This red line is a price and this blue line is a returns and the spikes are volatility. How much changes are there? See, price are decreasing, same time volatility is increasing. Over here, price is increasing, volatility is decreasing. Got it? It's a fact. I have taken the closing price and these are my returns. So volatility is calculated on the stationary data, on the return data. So this is, I make this diagram just to prove it that when the prices are increasing, volatility is decreasing. And when the prices are decreasing, this red line is decreasing, volatility is increasing. So that's why there is an inverse relationship over here. Got it? Any doubt? No doubt? Okay, now let's go with the EGAR. So again, over here, I don't have to check the preconditions again because we are using on the same, we are doing on the same graph. My stationarity is there, my volatility clustering is there, and my artifact is there. So now again, let us make the model. Same command will be there. Now same command. You don't have to remember the command. I'm just pressing the upward arrow. So when I'm pressing the upward arrow, my all the previous commands will be there. So I don't have to write it. So now let us create a model RN225. Now I'm giving the name EGARCH so that two different models are being made. So RN225 EGARCH is equals to UGARCH spec variance dot model equals to list model. Now I have to specify which model I want to make. So variance dot model is equals to list. Now over here, I'll write the name of the model. So model equals to EGARCH. Now I'm saying my model is EGARCH, comma, GARCH order is equals to C11. Mean model is equals to IRMA order C11. In previous command, I have not used the word standard GARCH. It's understood. It's by default. If you want to use, you can write SGARCH. You will get the same results. Now again, next command, I'm going to make it for the fit. Now let us do RN225 EGARCH fit is equals to UGARCH RN225 EGARCH fit data RN225. Now RN225 EGARCH fit. Now these are your results. Now see, these are your results. Now over here, omega is negative, alpha is negative. Now you don't have to worry whether alpha is negative or positive because we are doing the EGARCH model. It's a log model. So don't worry about that. Now beta is there. Now gamma. Gamma is telling you your leverage effect. And your gamma is positive. That means positive news has more impact than the negative news. And again, if you want to make a plot, just write plot Rn225 EGARCH fit and then 12. Now see over here. This is your 0, this is your negative news, and this is your positive news. And you are not getting a symmetric diagram. It's not a symmetry. And we have got the answer to be positive. Now you can see over here, your answer is positive and positive gamma. So it means gamma is positive. It's showing me that good news has more impact than the negative news. Now see, in the negative news, your volatility is decreasing. But in the positive news, your volatility remains almost same. It's changing, but it's near about same. So it is giving me better result than this. Got it? Now, let's move to your GGR gauge. GGR gauge is invented further. It was invented in 1993. And what does it says that in this we are using one dummy variable. That means we will be using 1 and 0 for the volatility, and it will give you the opposite result. If you remember right now what we have learned in your EGAS, in EGAS, if your gamma, I have written alpha 2 over here, you can use gamma. If gamma is 0, that means no symmetric volatility. If gamma is more than 1, more than 0, that means positive. The answer we got it. In EGAS, it means positive shocks will increase the volatility more than the negative shocks. But over here in GGR card, if your gamma is greater than 0, negative shocks will increase the volatility more than the positive shocks. And if your gamma is less than 0, positive shocks will increase the volatility more than your negative shocks. So GGR gauge and your E gauge volatility, this leverage effect gives you the opposite result. Got it? Now let's go with the GGR gauge also. Again, your same conditions are there. Now what I am going to do, I don't have to change any command. I'll just write GJR gauge over here, and over here instead of E gauge, you just write GJR gauge. Everything remains same. Now you gauge fit, let's say GJR gauge, and again also I have to change GJR gauge. And RN225 underscore GJR gauge fit. Now, these are your results. All your results are significant. All your results are significant. Now, over here, you will see that your alpha is not significant. Alpha estimates are 0 and it's not significant over here. Your beta is significant, your gamma is significant, and plus one more thing. Whenever we are doing your GJR gauge, how you are going to check for your post estimation, whether your whatever you are doing, it's good or not. That means whether there is a volatility persistence or not. In this, you have to write alpha. That means whatever the value of alpha is there, alpha plus value of beta plus value of gamma, and value of gamma is to be divided by 2. And whenever we are going to add all these things, it should be less than 1. If you remember in the S gauge, we have done alpha plus beta should be less than 1. But in GGR gauge, you have to remember alpha plus beta plus gamma divided by 2 should be less than 1. Got it? Any doubt? Your alpha, beta, and gamma all should be either less than either equals to 0 or greater than 0. In EGAJ, it can be less than 0. If you will remember, we got the negative sign of alpha. But in GJR gauge, this is a condition that alpha, beta, gamma, alpha and beta should be equal, should be more than or equals to 0. And gamma should be more than 0. If it's obvious, if it is 0, that means a symmetric effect is not there. So gamma is more than 0. Alpha and beta can be 0, but can be more than 0. Now, any doubt in these?
No, madam.
Any doubt?
No, no, madam.
No doubt?
No, madam.
Now, if I'll go with the stata, in stata also the commands are easy. Okay, let's import the file in this. Here, okay, so let me give the command that this is my time series data. Okay, I have given the command. Now, this is my, first of all, again, I have to go with the stationarity. So I have to convert this into stationarity. So I'll say generate Rn225 equals to ln n225 n225 divided by n225 bracket underscore n minus 1. Now you will see Rn225 is created. Now just write arch Rn225 comma arch1 arch. Now you will get the result. So you will get the arch effect, arch coefficient, and your Gauge coefficient and constant. And if you want to find the E-Gauge over here, you can just write arch Rn225 comma your arch 1 Gauge 1 and E-Gauge 1. You will get the result. You just click more over here. See, this is your result. Your arch effect, Gauge effect, and E-Gauge means your leverage effect. So you are getting the complete results over here. And if you want to make a line, so TS line, time series line, Rn225. If I want to check the clustering, these are your diagrams. Time series line. Over here, we are using the command plot.ts. Over here, you are using the command TS line. That means I want a line diagram from the time series data. So it will give you the result. So any doubt in your arch and gauge?
And what was the previous command from before eGarch?
You just have to write arch. First of all, write we want arch effect and on which variable Rn225 comma, and then give the command that arch, what is your model? So my model is arch1 and gauge 1. This is my model. So you will get the complete result.
And
And
same
if
for
you,
the JGR guards also instead of eGarch.
you just write GGR gauge. If you want N gauge, write N gauge, T gauge, T gauge. So
Okay.
whatever type of gauge you want to write, you just have to write it over here. So you will get all the results over here. But sometimes what you can find out that, see, R is a different software, your Stata is a different software. So sometimes in Arch and Gauge, the values of estimates that you are getting, that can be little bit different. For example, if you will see over here, this is my Arch value is 0.366, your Gauge value is 0.579. Now let's go with the R. If I'll go with the R, and let's say I'll just uh, this one, this gauge fit, I'll just put it over here. Okay, I'll leave it. I'll just give you the command over here. Let's go with the gauge fit. Okay, this is my gauge fit. Now see the results over here. Over here, my alpha is 0.145 and beta is 0.803. But in Stata, my answer is 0.366, 0.579. So sometimes it gives you the different results. So you have to be very careful in this. Otherwise, for each and everything, we get the same result. But in Stata, some results are different. So I personally never go with the Stata if I have to use the Arch and Gauge. Stata is good for panel data, but if you want to go with the ARIMA model or Arch and Gauge model, your R is good. For panel data, R is not so good. Your Stata is better than panel this R. And in e-views, again, some different results are there. And in e-views, I have seen that mainly the researchers get confused. I gave you this part that in e-views, it gives you the result by writing the first difference, second difference, third difference. People are not aware of why first difference is taken, why second is taken, why its level is there. They always say that if we are converting into stationary, it means first difference. No, it's not a first difference. It depends on our thing whether we want to take it as a first or not. Now, the next step for your GARCH model is your multivariate GARCH. We have finished with the univariate models now. So now, any doubt?
No, madam.
No, no one is having any doubt.
Ma'am, this
Yes.
Arch and Gauge is the univariate models.
Yes.
We can
Yes.
apply it in we cannot
Single
apply it
variable.
in we cannot apply in multiple variables.
In no multiple variable, some another extension of GARCH model will be
That will
there.
be the spillover, the
Yes.
DCC and Beck
The
Gauge.
DCC, BE, GARCH, your
Okay.
CCC GARCH. That
So,
will be your spillover.
for example, there are 15 variables. So we have to find the individual Arch and Gauge models for every
Yes.
particular variable.
Yes. If you want to forecast the volatility. But if you have to forecast the spillover effect, whether one variable is impacting the other or not, in that
Mm-hmm.
case, you are taking two variables at a time or more than two variables. Let's say
And
I just
suppose
give
there
you.
are 15 variables, then
So you can see whether one variable is having the impact on breast protein or not. So it becomes a multivariate.
okay, ma'am.
I can find out the impact. For example, I gave you in US. In
Mm-hmm.
this COVID-19 started from China, but it's
Mm-hmm.
impacted the whole world. So that means China is having the impact on whole world. I can study all the countries of the world. You can, if you are able to study all the countries, take out the data of all the countries and take the data for China and then see the impact.
Okay, ma'am. Okay.
So I can see the impact on one variable, impact on another variable, or one variable impact on next two variables or next three. It's up to me. In one shot only I can take it. I don't have to apply. I don't have to make the model for two variables. I can do it in one shot. Your R will do in one shot. But your DCC guards will or BKK guards will just tell you that whether there is a spillover effect or not. It will not tell you how much effect is there. For example, if I am saying that right now, whatever I am teaching, and I am saying you have to write one research paper. So it is impacting you. You are thinking, yes, yes, we are able to understand, we will write a research paper. So it is impacting you. DCC guards is telling me this much only. But whether it is being impacted to you 10%, 20%, or 100%, you will write a paper. That DCC guard will not tell. Whether I'm having a positive impact in your mind or a negative impact, that DCC will not tell. For that, you have to go with the connectedness approach, Diebold approach, and Boric approach. And this Diebold and Boric are the recent approaches. That is, or you can find out whether your, let's say I'm taking two variables, I'm saying that yes, one variable is impacting the other. But from these two variables, which is a lead variable, or which is a lag variable, that is not going to tell by DCC guard. For that, I have to go with the wavelet analysis. Which is the leading one, which is the lag one. Got it? So that means
Yes, ma'am.
we are in the line of future research, but right now, step one by one. So univariate is finished, then multivariate, and then further extension, and then further extension, and God knows whatever further models will be created. Economists are sitting, they are making the models. We are just learning these models and just applying it.
Okay, ma'am. Ma'am, there is just one question. Uh, on in E gauge and this JGR gauge, both are asymmetry one.
Yes,
So
both are
which
asymmetric.
one is more reliable, if we can say, or should we go for the literature review?
No, 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 no. For that, I told you in Arima also how we are
Mm.
going to compare two things by AIC and BIC.
Okay, okay, okay.
For everything, whenever you have to compare which is the best, calculate the AIC, BIC of your EGOT and calculate the AIC, BIC. You will see na in, let's say in R only, you will find AIC, BIC. See, this is the information criteria. AIC, Ekaika information criteria, base information criteria, Shabita information criteria, Hanen-Kuhn information criteria. In this way, you can get it for e-GARCH also. For example, this is, I have find out, you can just see, this is for GARCH model. And what I can do, let's say I write e-GARCH also. Okay, let's go with the e-GARCH. And if you will, I have given the answer for e-GARCH. And over here also, you will get AIC. AIC, BIC, Sabita, and Hanen-Kuhn. All the information criteria will be there. You just make a table, one table for standard gauge, then for e-gauge, and then for your GGR gauge. Okay, okay, let me show you one thing. Okay, I'm stopping the recording. I'll show you one paper because I don't want to make it publicly.